Alright, let's look at the fourth questions of the 2006 paper. Before we tackle this very simple but a problem which requires a lot of understanding about slope and second derivative, I'm going to do one short investigation. Get my GeoGebra going. So this graph, you'll see the pink color line is a tangent, and the m, which is slope of the tangent, is shown. I want to move this. You can see that is, if you see, you can do something like a ruler test. You place your ruler on the curve, and then you kind of like traced it. You see it's negative. Of course, it's slanting down. At this point, is a minimum, the local minimum. That's why the dy dx, or the slope, is 0. Now it goes to positive because it's going uphill. In your ruler will look like that, and then it's 0 again. It's going all the way downhill, and the slope is negative. So with that in mind, okay, positive, 0, and negative. That's why when you do a sign diagram, you see something like a negative and positive for a critical value. You know it's a local minimum. When you see a negative, positive followed by negative, that particular critical point would be a local maximum. Alright, let's return to our point here. Okay, so we know then they ask you clearly mark and label the graph above a point P. Now before I continue, there's actually I think there's a mistake in printout. There's actually the point S here, the local minimum. Now okay, now mark a point P where f prime is positive. Now f prime, if you recall, is actually slope, and I hope the investigation just now impact upon you that when you see you do a ruler test and you see that it's slanting up, that would be where the part where the slope is positive. And so this is the area, this all this area between here and here is positive. You see all this here, because the ruler we're going to test is going to show it's going to slant up. And then the f double prime greater than 0, and so I show you a theory, and you must understand and remember the theory. The point T is inflection point, non-stationary inflection point. So, and looking at the shape of the curve before point T, it is actually convex, and when it's convex, your f double prime is positive, and after point T, it is concave. It's like a mountain, right? And so the f double prime is negative. So they want an area where the f prime is positive, the slope is positive, and f double prime is positive. There's only one such region, and that is between S and V, and for f double prime is between S and T. So as long as you place a point P anywhere, just plot the point P anywhere, that will be it. Let me erase it. So what you need to do is, there's a point S, it should be in the questions, should be given actually in the questions. So all you have to do is just plot a point P anywhere between S and T, then you get the right answer. Moving on to this one here, by referring to the point STUV, again the S should be here, STUV. Given the diagram, fill in the blanks below by indicating positive and negative. Now f, function f, is just whether the point is above or below x-axis right here. So s is obviously below, is negative. T is above x-axis, it's positive. U is below, negative. V is above x-axis, so therefore it is positive, right? And f prime, now these two, S and V, both of them are actually local maximum minimum. So f prime for S, f prime for V are 0, and then for T, f prime, this is remember, this is about the ruler test. It's slanting up. If you draw a tangent, slanting up, So at t, f prime is positive, and at u, f prime is, of course, going this way, so negative it is. And f double prime, because before it's something to do with concave and convex. Here is a convex, and t is your inflection point. Right? Before t is f double prime is positive, as we have seen just now. This is a concave, so after t, f double prime would be negative. So any point before t, so in this case u and s is they're before t. I mean to the left of t should to be more precise. So u as f double prime of u and s would be negative, or should be positive and positive, and because point v is to the right of the point t, which is the inflection point, and hence this is a negative. And finally, f double prime will always, since t is an inflection point, point t you sub into f double prime will give 0. So remember that. See, I hope you can understand this, and try to find some other functions or graphs from books and so on, and try practice of them and do this table, and you will learn a lot by doing so. And all the best.